Hello there, 20-1s. How you doing today, or this morning, this evening, this afternoon, whatever it is for you? Hope all is going well. So now that we have talked about how to solve equations, quadratic equations at that, well, we're still going to do some solving, but we have solved graphically on the calculator, and we have solved by factoring. Well, before we go on to more solving, just a quick little piece that is important, and that's now to be able to go backwards and create an equation. So we've had a situation where we've had a quadratic equation and we've created the roots. X is -2 or X is 5. We now know that. But the question is, what if you have the roots? Instead of calculating the roots, can you create the equation when you're given the roots? So if you have X is -2 or 5, what's that equation that you started with? And that's just one of those, after you learn to add, you learn to go the other way and subtract. You learn to multiply, you learn to go the other way and divide. And that's what we're looking at doing today. So if we are given X equal to 3 or X -5, X equals -5, we want to determine what's the quadratic equation that has these as roots. So essentially, we need to end up with 0 equals an ax squared plus bx plus c. This is what we need to get from this information. Well, really, there's two steps. We need to figure out the roots in factored state, and then we need to expand using FOIL, because FOIL will give us that form that we're looking for. But it's this first one that's a little different, something you might not have seen before. If we think of it, how did we know that x equaled 3? Well, we knew that x equaled 3 because we had something that had to have a value of 0. But what we were doing before was taking this to isolate the x. Well, now, instead of isolating x, we know x is 3. We want to create the 0. What do I have to do to get a 0 here? Well, I need to subtract 3, so I subtract 3. All we're trying to do is to get a 0 because we need one of our factors to be 0. Well, if x equaled 3, what was our factor? Our factor was x minus 3. And just like if we had that x equaled -5, well, what if we wanted that factored form to have x equal to -5 and have a value of 0? Well, we need to turn this into a 0. So we're going to add 5. X plus 5 is the factored state that gave us our 0. So how do we end up with this equation equal to 0? Well, if x were 3, that means we started with x minus 3. If x was -5, we started with x plus 5. So there's step 1. We've written the roots in a factored state. X minus 3 times x plus 5. But we're not finished because we want a quadratic equation. So now we need step 2, and we need to FOIL this. So we're just going to take x minus 3 times x plus 5 and FOIL it. And that will give us x squared plus 5x minus 3x minus 15 equal to 0. Combine our two like terms. X squared plus 2x minus 15 equals 0. There's the quadratic equation that has x equal to 3 or -5 as roots. So that's what we're looking at doing. Taking the roots, creating the equation. Let's take a look at another example. I don't believe this one is in the booklet, but it's another one with nice whole numbers. So again, x is -6 or x is 10. Well, we need the factored state. And it has to equal 0 because that's what a quadratic equation equals, is the 0. Well, if x equals -6, but we want it to be a value of 0, you're going to add 6 and add 6. So x plus 6 equals 0. There's your factored form. But I need to do the same thing for 10. So if x equaled 10, that's our x value, well, we want a 0 value. So I want it to equal 0. How do I do that? Subtract 10 gives us our 0. Subtract 10 here, and we get x minus 10. So there's your second factor. So we're just doing everything backwards. Instead of factoring, setting it equal to 0, isolating x, well, now we take the x and we get it to be a 0, and then that expression goes into that factored state. But the factored state isn't what we want. What do we want? We want the quadratic equation. So step 1's done, and now we expand using FOIL. And we end up with x squared minus 10x plus 6x minus 60 equal to 0. X squared minus 4x minus 60. There's the quadratic equation that will have x equal to -6 or 10 as roots. There you go. So, as long as you understand the process, it's not too bad. Except, situation, a little bit different. We have a fraction here. X equals -3/5, and then a whole value. Well, the big thing here is that when we're writing in factored state, we don't want fractions. So, if we don't want fractions, it's a little bit different. We know that x is -3/5. We want it so that this now is 0. Well, it's not simply a matter of adding 3/5 because that keeps the fraction. It's not that simple. Wish it was. Because we're dividing by 5 here, we need to multiply by 5 and multiply by 5. So what do we have? Well, this becomes 2 steps. We have 5x equals -3. Because this was divide by 5, we multiplied by 5. And that left us with our 5x, and we still have the -3. But at that point, I want it, remember, to be a 0 over here, so we're going to add 3, and we get 5x plus 3. There's our first factored state. And now the 4, well, we have x equal to 4. We want it to be 0. So we're going to subtract 4, and x minus 4 equals 0. So that's our second factored state. And a quadratic equation has to equal 0. So we work with the roots, put them into factored state, and now we FOIL. 5x squared minus 20x plus 3x minus 12 equals 0. So our quadratic equation, 5x squared minus 17x minus 12 equals 0. There's the quadratic equation that has x as equal to -3/5 or 4 as roots. So there's what we're looking at. Last one is to determine the quadratic equation. Well, positive or negative root 15. So in this case, x equals root 15. And the second situation, x equals negative root 15. Now we come across this because remember, exact values are important. Obviously, you're going to see as we move along, sometimes we use exact values instead of rounded numbers. Well, it's not a lot different. I want an expression equal to 0, so I'm going to subtract root 15. Subtract root 15. What I have, take it away, gives us 0, and we're left with x minus root 15. Do the same thing here. We want this to have a value of 0, so we're going to add root 15. Negative root 15 and a positive root 15, there's our 0. But I have to make sure I do the same thing to the other side. X plus root 15. So our factored state, x minus root 15 and x plus root 15 is my quadratic equation. From there, now we have to FOIL. FOILing's a little different with the roots, but still manageable. X times x is x squared. We get x times root 15, which is just x root 15. And then we get negative root 15 times x, which is negative x times root 15. And now from last year when you did radicals, a radical times itself just leaves you with the radicand. We get a minus 15 because root 15 times root 15 is just 15. So we simplify, well, x root 15 and negative x root 15, the positive and negative of the same thing cancels out. So x squared minus 15 equals 0. There's our quadratic equation with x equal to positive and negative root 15 as roots. So, little quirky little thing that you need to understand how to do. Not a big assignment, it's a small one. Give it a try. Answers are in the back of the book.